Okay, so what I'm going to do now is have a go at making the fuselage, but as a folded part. So at the moment we've just got a placeholder part in here, which is just a shell. In reality, when we're going to build this, it's going to be made out of a series of flat folded bits of board, cardboard or foam board, and we want to be able to draw that in CAD. This is relatively advanced use of CAD. You have to use the sheet metal facility in SolidWorks to do it. It's great when it works. It's not easy, not for the faint-hearted, but it's very powerful in the sense that you can draw folded up structures in SolidWorks, unfold them, and then get the drawings for laser cutting. So I'm going to have a go at doing that. There's a couple of ways of doing it. I'm going to start off with, I think, the simplest way, and we'll see how that pans out. Okay, so I'm going to start a new part, and it's going to be the fuselage, so I know that it is, we're going to do it on the front plane, and it is a square 250 by 250. So let's dimension that up. So 250 by 250. And that's going to be our outline, but to generate this as a folded part, what we really need to do is then draw a spiral of what we're going to be folding up. And easiest way of doing this probably is to draw if it's a 5mm thickness material, it's probably easiest to draw the center line of that and then do a offset entities relative to it. There's some quirks in that when you're making up the folded structure, there needs to be a gap for you to select surfaces, so you have to make the surfaces slightly smaller. Excuse me. Let's have a go at drawing this anyway. I'm going to convert this to a for geometry. Did two of them. And I'm going to assume we're folding it up. We're going to assume this is the base of it, and we're going to fold this thing up into a spiral. So I'm going to get some lines on to start off with. We can worry about converting them to other stuff later. So I'm just going to draw myself a spiral. And in fact, before I do that, I'm actually going to delete these lines because they're just going to get in the way of me. So I'm just going to... So it doesn't matter exactly where they are. They want to have the references to be horizontal and vertical. You can hard code those in if you want. And what I'm going to do is 3 spirals, so assuming it's a wall thickness of 3 layers. How many is that? That's 1, that's 2, and this is the 3rd one. So I'm sure there's ways of automating this, and you can work it all out in Excel to start off with, but I'm just going to kind of hand do it here because it's probably quicker first time around. So if the material's 5mm thick, we need to start 5mm in. So let's just do that. So this is relatively tedious to do, but it's worth it in the end. Okay, that was concerning. 2.5mm. So carry on round here. 2.5. Now we're reaching the next level of the spiral, so the distance between the centres is now 5mm. Oops. As ever, you have to be careful where you click. Yeah, thanks SolidWorks. You can do something similar to this by just doing offsetting squares to start off with and then snapping onto those, but it's not always easier. And the great thing about CAD though is once you've done it, it's there and you can change it and whatever it is afterwards, rather than if you make something it has to be done over and over again. Okay, so that's got our dimensions in. I'm going to pull this down. Okay, we're losing those. Okay, I'm going to stop there because I took the centers off. I am going to lock these in place so they don't move. Okay, always be wary of blue lines on your CAD because they're not fixed to anything. And with this, we could do it all the way to the bottom. So happens when you're folding it, if it's too close and the fold interferes with this last thing, it won't fold it. So you have to pull it a little bit short, this last one. And this one is going to start at the end. So that's our spiral, and what we now need to do is offset the kind of material thickness from that. So we're going to do offset entities. We're going to select chain. Hopefully it'll just select the whole thing. We are going to have it, it's going to be 2.4 either side. So we're going to leave a little bit of a gap, and that's just so we can see where the gap is. And it's going to be bidirectional. We're going to cap ends with lines, and that's not worked for some. It's worked for that bit. I've obviously got dimension wrong on that. That's okay, I think. Okay, so that was nearly a win. Okay, and the other thing I forgot is, will it remember everything? Yeah, we need to then set the base geometry to construction, so it gets rid of the original line. It's looking promising. So there's obviously an error in this offset. Yeah, I typed in that wrong, so in theory we should just be able to do 2.5, no, where 1.25 came from. Yeah, and we got it. Okay, that's our spiral, and the way we're going to do this, we're going to make it as a solid, and then we're going to unwrap that as a piece of sheet metal. You can do it the other way around. You can draw flat and then draw folds on it and fold it up to make something, and this is easier to do to start off with because you know what you're seeing. So let's extrude that as a feature, and oh, it doesn't matter how long it is. I think I did it in 2 goes, didn't I? So let's do 1.5 meters that way, and I can't remember the exact numbers. It might have been 2 meters the other way. Okay, and good old SolidWorks done its job, and we've now got that folded structure. But our challenge is, if we need to be able to make this from laser cutting, we need to get a DXF of this bloody blah. So what we need to do is unfold this. And what we're going to do then is convert this to a sheet metal part and then use the automatic unfolding. And the other key thing that using sheet metal does is it applies a bend correction to each of these things. Because actually, if you unfold this directly, and make the fold lines where the kind of rigid straight lines are, it'll be the wrong shape, because actually you lose material on the corner, or it takes a shortcut on the corner, so you have to do a correction on each of the bends to get it the right shape. By experience with 5mm foam board, if you do a 2mm radius, so losing 1mm on either side when you make a bend, that comes out about right. So let's convert this into SolidWorks, into sheet metal. If you've not used sheet metal before, it's like learning a whole other package. There's a whole lot of other stuff you have to learn and understand conceptually about what it's doing. And as ever, when you start shouting at it, it's normally because you're trying to do something that wasn't designed to do. So if you understand what sheet metal's trying to do, it quite often helps you de-stress in that you go with the flow rather than trying to fight it. So we're on sheet metal. It's quite a lot of terminology. You have to send this flanges and all sorts of things you have to worry about. What we're going to do to start off with is create a, this is a terminology, base flange tab. So basically we're going to create a sheet metal object. Okay, no, I completely missaid that. We're going to do the next one. We're going to convert to sheet metal. Okay, so that's the one if you're starting from flat. This one is we need to convert to sheet metal. Okay, so it's found what I was working on. And then all these parameters come up here. The first thing you need to do is you need to tell it which is the fixed bit, because you've got to have some reference to where the folds are. It's not in clear. Select a fixed entry. And somewhat cryptically, because we're going to be doing the folds on the corners, we need to select an inside surface. So this, you can see why we left a gap now. So what we're actually going to do is select. You can do this. Why isn't it allowing me to select anything? It's all gone transparent. Slightly weird. Okay, second time lucky. So I've selected that inner surface there, and that's going to be our reference where we start from. The thickness of the material is, we're actually using 4.8 millimeters. Truth be told, I'm not sure whether this uses it as part of the correction or not, and we should put 5 in or not, but 4.8 is close enough. Okay, so ignorance warning there. Bend radius of 2 millimeters is really important. So typically when you make a bend in Foamboard, 2 millimeters is about right. And we're also going to set the correction coming up. We're going to do that down here. So we can leave the corner defaults, and then the custom bend allowance. What you want to do is put bend deduction in there, and we're going to have 2 millimeters. So this was done entirely by trial and error, but we found that when we're making these boxes, if you put a bend deduction of 2 millimeters, when you actually build this thing, it comes out the right size. So it's obviously related to the bend radius, but essentially we're losing a millimeter on each corner. And the thing we need to do now is give it the bend edges. So this requires some rather careful clicking, but what we're going to do is go around each of these edges. So clicked on that first one, that was a success. You can see it's actually put the bend in there with the radius. Let's change colour, and what we have to do is go around and do all of these. So careful clicking required, and at each stage you have to check that it's found it. Sometimes it just doesn't find an edge, and then sometimes you just have to stop and start again, and it finds it second time. Obviously sometimes it's you clicking in the wrong place, but sometimes it just won't find a corner. And sometimes that's due to an intersecting geometry from somewhere else. If there's something sticking in the way, it just says I can't do it. So we seem to be getting lucky this time. It seems to be working. And obviously it's a bit weird. We had to leave a gap to do this. But obviously if you don't leave a gap, you can't see where the edges are. I guess normally in sheet metal you're not used to folding things on top of each other like Swiss rolls, so you can normally see the edge on your component, whereas with this we can't. Alright, this is going really well. Normally there's some fail at some point where it says no, I can't find that edge, but we seem to have Got lucky today and it's finding them all. Lost orientation. Okay, so that was a win. It's found all the edges, it's all gone that green colour. And click the magic button, tick, and it goes away and thinks about it. And there, it's done it. Okay. If you get it to work first go, you've done really well. Normally it takes multiple attempts and you might have to start on just one bend just to get the hang of what's working, but you can tell it's worked because it's now replaced everything with these bends and it's the shape we want. Okay, I was actually expecting that to take longer. Now this is where the really cool thing happens. If you go to flatten, it now unrolls your pattern in this, and if you want to see where the bend lines are, if we, well, it's a bit weird anyway, but there are bend lines. So if we now DXF this and put these as score lines, when we when we roll it up, it should turn itself into a tube. What next? Okay, I think I'll before we do anything else, I'll show you how to use these bend lines, because it's not completely straightforward. This is a sketch, but it's kind of caught up in this, so you can't use it directly. So let's draw out the bend lines. So what I'm going to do is create a separate sketch.
Bend lines in a sketch can be used to create bends in a sheet metal part.
I did not ask you, Google. I did not ask you. That was Google was listening. So what you can do is convert entities, and this sometimes works, sometimes doesn't. Where is it? Flat pattern, bend lines. Yeah, okay, so it doesn't seem to recognize those as something you convert, which is weird. So what you have to do is, if we get the bend lines up, yeah, okay, I think you probably have to do them one at a time. So if we go here, convert entities, and then we can't see them, bend lines. So if you select them individually, it works, but if you select the whole sketch, it doesn't. So that sketch has something funny about it that you can't access these lines. So is this going to work? Okay, so that worked. Another one of those anomalies, you click the sketch, it won't convert it. You manually click all the individual lines, it does. So there we go, we've got our thing, and then you need the same for the bounding box, because this bounding box is dependent on the folds and everything else. So yeah, let's get this at the same time. Convert entities, and will it allow us to grab these edges? Yeah, it will. So you might ask, why can't we just use these original sketches? Don't ask me, they're kind of caught up in this flat pattern, so you have to basically recreate them. You can do things like copy and paste of these sketches into another sketch, and that kind of works, but you always have to be a bit careful cutting and pasting things in SolidWorks. Sometimes it keeps the right references, sometimes it moves it. I'm just going to try that now because it's slightly could be quicker. So anyway, let's call these bend lines, but if we wanted to be really quick about this, let's just try it. So if you right click, there's no copy, but if you just do Control C, and then you have to select a plane that you're doing it on. So this is on the front plane. It's a bit weird. No, it wasn't, it was on the top plane. And then you do Control V. What happened then? Is it done on top of the other sketch? No, they're just there. Okay, my bad. I was already in a sketch. Okay, that was bad. Right, come out of the other sketch. Let's do this properly. Bend lines. So actually, you can copy a sketch into another sketch. So that did work, didn't it? But we want to paste it into a new one. Top plane, Control V, and edit that. Okay, so that did work, and it's in the right place. So instead of doing convert entities, you can copy the sketch and paste it out. Although I have had issues if you then subsequently use this sketch to create bend lines, it says it can't do it because there's something about joining things. Okay, so this video is getting very boring and detailed, but these are some of the issues you're faced with. In that there's no set pattern of doing this. You have to try it. Sometimes it works, sometimes it doesn't. Okay, so I can delete that, so we don't actually need that. Alright, no, I'm still in folded up mode, so I have to exit the sketch here, not there. So I can delete that. Yeah, that's gone. So bend lines, then there's if you want to make this, then you have to do the split it up into different sections. Are we going to do that now? Okay, I'm not going to do that now. This is obviously like a massive sheet now, 3 meters by whatever it is. And to get this laser cut, you need to divide it up into separate panels and obtain the drawings from those. I'm not going to do that now. I can come later. What I am going to do is roll this back up. So one of the really nice things you get with this is if we want to put some holes in the side of here, we can work on this solid, and then when we unwrap it, all the holes and everything else get brought into the 2D unwrap part. So if you imagine there's various tabs and connection points for undercarriage and everything else, we can include those here. So what I'm going to do just as the first thing is draw some holes in the side. It's nothing scientific. I'm just going to do some weight reduction holes. I'm going to have them on the center line. I'm going to make it that big, and I'm going to do a feature extruded cuts all the way through, and then I'm going to pattern that along the axis, and I don't know, 250 between them sounds about right, and then go to the end, slightly less. So there I've just made some sort of random weight saving holes in there, on the basis this is like a beam and most of the work is being done by the top and the bottom, but obviously with the fuselage there's other loads in it, so that naively just cutting holes in it is not necessarily a good idea. But then the magic is if we go back to the sheet metal and we flatten, we've got all our holes in the part. So if we look at it from the top, they're all being put in for us, and that saves a huge amount of time, because if you had to individually work out where to put these holes in, it would take you forever, and it would really not be good use of time. Okay, so that was quick. The other way of making these sections is to draw the bend lines yourself and then fold it up. So what I'm going to do is quickly show that. So I'm going to quickly show that. Tell you what, I'm going to stop this one here. So that is how you produce a rolled up part quickly. It's uniform all the way along, but you can cut holes in it. Jobs are good, and that's a win. So hopefully if you've seen this, you know how to use sheet metal for that. And in the next video, what I'm going to do is show you how to do it the alternative way, by drawing the lines, then folding it up. Okay, so in the previous video I showed how to make a rolled up part starting with the finished shape, and then we're flattening it to make the sheet metal, and that's one way of doing it, and it's great when you put holes in it. The only thing you can't do with this one is do tapered structures. So if you want to internally taper your beam so it gets thinner towards the edge, it's very difficult doing this because you can't cut the holes in. Effectively, you have to take the material out of the inside. What you want to be able to do is take this and then just cut a diagonal corner off that, and then you roll it up and you get your sort of croissant shape inside. So just the way the flow works on this is flattened. Anything you do on here is not fed back to the other part, so you can't actually see exactly what's going on. Okay, so what we're going to have a go at doing then is designing this by drawing the flat pattern first and then rolling it up. Just for a quick go, just to get the hang of it, if we just take a kind of random thing, just do it really quickly, and let's draw a rectangle. Oh, it really annoys me that SolidWorks starts with an empty sketch. Never used to. Okay, so let's just draw a random shape, and we're going to tell SolidWorks this is going to be a sheet metal, and then we're going to roll it up. So I might as well do that to start off with. If we go to sheet metal, and then this is where we click the base flange tab, create a sheet metal part, first feature in a new sheet metal part. So it's remembered the properties I used before. Said it's 4.8 millimeters thick. And so what, I'm just going to change that to 5 here. Same bend allowance, auto relief. Not entirely sure what that does, to be honest. Bend deduction 2 millimeters. We need that. It's actually looking a bit small, so let's just edit that and make it bigger. So it just means that when we fold it, it's not ridiculously chunky. Yeah, that's fine. So what we want to do now is put some fold lines on this and then fold up with that. So we need to create a sketch for that. So top plane sketch, and let's just bang on some fold lines. And it doesn't actually matter where they start and end. I'm just for neatness, I'm going to join them up to the edges. So really just needs to know kind of a vector of where the fold is. That'll do. So those are going to be our fold lines, so I'll give them there. And what we need to do is go on, we're on sheet metal, and what we want is sketched bend. So bend parameters, fixed face, so it needs to know where to start from, so we assume that is the fixed base. Oh, that's weird, it's picked up that sketch immediately. Okay, sometimes SolidWorks is really smart. So that sketch I did then, it just assumed that was going to be the bend lines. How did it know that? Is it because I had that selected? Okay, it's surprising when things work when you don't expect them to. But so if we look at our sketch bends, it's just picked up the fold lines. Maybe just because I put the sketch there, maybe because I called it fold lines, it found it. But normally you have to tell it where the fold lines are. and so each of these are now bends. So previously we took a solid and then told them they were bends. This time we took a flat thing and it's folded it out like this. Clearly that's not a very good spiral, so what I can do is, which way is it? Folding it. Where did it start? Did it start with that one? You can do the flattened thing. Not showing the fold lines. I think that's quite confusing of what it actually started with. It should have started with the okay, yeah, I think it did start with that one, then folded that one around. Yeah, okay, so actually the one we need to change is that's 1, 2, 3, 4, 5. The fifth one needs to be a bit longer. So if we edit that sketch, 1, 2, 3, 4, 5. That one was too short. Okay, I'm really. Oh, this is a good mental test, isn't it? So along, up, across. Let's make that one a bit shorter. That one's down, and then that one's across. And if that one's longer than that one, it should work. Okay, so not very scientific. Well, there we go. Okay, we've got a spiral. So clearly what you need to do is work out the lengths of each of these to get it to spiral to fit exactly. The challenge is that these fold lines have to take into account the bend allowance, so you lose your effectively 2 millimeters per side. So what you can do is get an Excel sheet, if I can find it. So on this one I did something earlier for I think it was this fuselage. So I started at 250. We've got a bend loss and then a thickness, and you can work out the dimensions of each of those bits and then roll it up. It's much harder maths than you might imagine, because yeah, they're not all the same. It's not like four the same. The one on the last one has got a bit taken off and then a bit more on the next one and so on. So you can just work out the lengths from sheer geometry and do it, and that. So you could label up all these sketches, all these fold lines with those dimensions, and you could work it out from there. That's fine. The other sort of hybrid way of doing things is to draw a spiral and then get the sketch from that and then use that. And the reason you might want to do that is that it's actually easier drawing the sketch in solid itself, when you don't have to worry about the bend allowances. Then SolidWorks generates the lines, and then you can produce something like this. I guess you may be wondering, why on earth would you bother to do that? The real reason is okay, I'll do it properly. So let's go to the folded test piece, and what we want is this bend lines sketch. So if we copy that, yes, probably work. Let's do it in a new file, and it was done in the top plane. Oh, stupid SolidWorks has got sketch open, top plane, paste, and sketch, edit. Okay, so we managed to get our thing across, and it's in the right place, so our reference is in the right place. Sometimes when you paste the sketch, it loses where the starting point was. So what we can do is we can use this to roll up. And again, you may be wondering, why the hell are we going out and then back again? But you'll see in a minute why you might want to do this. So let's create a base flange. So actually what I need is Ben's complete sketch. I need to get the outline and the other bits out of them. So let's do top plane, new sketch, and I want convert entities. So to start off with, I just want the edges. What's it doing? Convert entities. I did click on that. Oh, it's not. Okay. Don't know what I'm doing sometimes. I thought I started the sketch. I clearly didn't. Right. Convert entities. I must. So this is the outline. The great thing about SolidWorks is you can sort of be working and actually you're on a different planet to what the software thinks you're on, and you're doing stuff and you realise you've been working in the wrong sketch or whatever it is. There's something about the user interface, you can just get out of step with whether you're in a sketch or not. I guess when you get more experience you do it less, but I still find myself doing ridiculous things like that. So that's our outline, and let's do another one which just has the bends in it. And this may seem slightly pernickety, but what you find is the bend sketch needs to be very clean with only just the bends in, else SolidWorks will get confused. And this is the bend lines. So we're going to do what we did before on that sort of scrap part. We're going to go to sheet metal, base flange, 5mm, bloody blah, that's all fine. And now we're going to do our sketch bends, but we're going to use the bend lines. And boom. Okay. Yep, so that worked. So we made this part, we flattened it, took all the bend lines off, made another flat part, put the bend lines on and folded it back up again, and we've got exactly what we started with. So it shows the process is reversible, but the reason we're doing this is if we now flatten this out, we can now do stuff on here that will get rolled up, whereas before, because this unroll bit was the last bit in the chain, it didn't appear back in the solid. So we can now do can we do this flat pattern bend lines? I think no, actually I lied slightly. We have to go back to our base flange and the outline. So if we want now a tapered spar, to use your mind bending, so you want the outside bit to be the last bit. Okay, let's see if this works. So what I'm going to do is go out 1, 2, 3, 4. So those are the edges. I'm going to come straight from there, and we want it to roll up. Maybe come down to here. And then I'm going to trim off that. So now when we roll this up, the spar will be thick at one end, getting thinner to the other end. And I did it wrong, but anyway, that's fine. So now it's tapered the wrong way. So you can see what's happened now. It's rolled up that. You can see why it's called a croissant type of spar. It's got more. It's got one layer of pastry at that end and 3 layers of pastry at that end, and it goes out. So there's nothing wrong with this, but this would be a pain to work with because the outer geometry is changing. But I've, in my head I got it the wrong way around when I rolled it up, so no problem. Get that, and can I undo that? No, it's going to go all the way, isn't it? Yeah, that's fine. Still in the sketch. So what I should have done was done it that way around. Come out of that, and okay, we've got what we wanted. So now if you look inside there, that's a spiral wound spar or tube that gets thicker towards the end. And you may think, well, was it worth all the bother? Typically these wing spars and tubes are the heaviest thing on the aircraft by far, and by spiraling it, or sorry, by tapering it, you can take out 30% of the mass. So on a 25 kilogram aircraft, you might be able to take out 3 kilograms of foam board just by tapering these things. So it really is worth doing. And we can also do the thing here where we do the cutouts. So I'll just bang in some cutouts here. Flat bits there. Okay, that's fine. Has it gone all the way through? No, it's changed. Line through all. That's strange. Sketch plane through all both. Why didn't it cut it? What have I done wrong? No. Yeah, still unable to sketch plane through all both direction. Why is it not liking this? No reason why this should be different. Let's just try again. Extruded cut. Maybe because it's not getting to their detail preview. Okay, that's useful. So let's do blind, and then I'll just tell it what to do. Okay, are we in the wrong place there? Can we do it the other way? Okay, so this is not going well. Wonder why I can't do this. I'm doing something wrong. Wonder if we can just do it through one to start off with. No. Alright, let's cancel out of that. Discard changes. Why didn't that work? I should be able to cut holes in that, or maybe I can't. I've rolled up thing. I should be able to. Okay, so I think I've got I'm confused here, aren't I? Because we've done it the other way. This is the final result. But I should be able to cut holes in it. It won't unwrap them. Oh, let's have one more go. Yeah, it's curious that it's not found all the geometry. That's weird. Okay, so that did work. I'm just curious now why that's struggling. Is it because we're cutting through the sheet metal? Yeah, so it doesn't like that. Alright, okay, well I might have to just quit while I'm ahead on that, and then we can do a linear pattern and down the beam, and what are we doing? I've got extrude. Why isn't it giving me a preview? Because I've only got 14 and 250. Okay, so there we go. You can put those things in afterwards, but I guess the thing to point out is that when we flatten that, okay, that does work. Okay, so now we can put the holes in afterwards, of course, because that's easy. What we couldn't do before was cut this bit out. This cut had to be done at this stage because that was the right way to do it. I'm now just curious to know, presumably we can put cuts in here, can't we? So, okay, this is like real experimenting on the fly. But if we do a sketch, and try and cut a square out of this. Features extruded cut. And then sheet metal. Is that, they gone inside? Did that do anything? Should have done something. What did I do wrong? Let's have another look. Base flange outline. Sketch. Let's unfold it. So yeah, usual apologies for incredibly dull videos, but what you're seeing here is what it's really like to do these things. So I'll try and make that bit bigger. It's done there. Did I need to do that earlier? Okay, I think the issue there was that I did it on the flat pattern afterwards. So that's okay. So this, if we then derived a DXF from that, in the real world when we folded it up, it was there. But in the SolidWorks world, it's only folding up the base flange, so anything we do after that is not going to appear. So this is why I think sheet metal's hard, because you have to think of where you are in the process and which order you do things in. So I think what we needed to do, it won't let me do this, I'm sure, but this needs to go further up here. Okay, it won't let me do that. So let's delete that. So what happened there was I put that feature in after it had done its stuff, and what I need to do is actually put it in the original part. So if I now do a sketch, okay, we're in the sketch, so if I now do the same thing, I've cut a massive great hole in it. Features. Rectangle. Okay, of course this is just a sketch, isn't it? What's he going to do? Is he going to treat that as a whole? No idea. I did treat it as a whole. So yeah, the outline for our base flange was a sketch. So that's flattened, unflatten it. Okay, yeah, so now it has missed out that bit, so we've got a big square hole in it. Okay, only goes to show no one really knows. Well, I don't know what I'm doing. I'm sort of trying stuff out, and depending on when you want to put the design geometry in, you have to do it in different places. And sometimes you get yourself boxed in where you make a lovely shape and then you find that you have to have done something earlier, and the method you're using doesn't allow you to do that. Anyway, so I think if you'd watched this video on 3 times speed, you will have picked up some of the things you have to do to try and make things work, but also it's just really showing the thought processes that have to be put in. I'm sure there's an easy way of explaining these things, but it tends to be quite non-linear the way you experiment with CAD till you find a way of working that fits the part you want to make. Okay, so I hope that's a bit useful.